Good morning, students. Once again, I welcome you to my video lectures on network analysis. Now, we have come to the fourth type of problem on mesh analysis. So, fourth type will have dependent sources. So, here there is a dependent source. So, this is a current controlled current source. So, I1 is the current which is controlling this dependent source. So, this is type 4. So, what is the procedure is the question. Now, first of all, you find the number of meshes. As usual, first step is to find the number of meshes. So, there is one closed path, another closed path, another mesh. Three meshes are there. Or you can use this formula B minus N minus 1. B minus N minus 1. Number of branches 1, 2, 3, 4, 5, 6. 6 branches. Number of principal nodes 1, 2, 3, 4. 4. That is 4 minus 1, 3. 6 minus 3 is 3. So there are 3 meshes. There are 3 meshes and you can mark them as I1, I2, I3. I1, I2, I3. Now I will mark this as I1, this as I2 and this as I3. This as I3. First you have to mark in any direction you like the meshes. So having represented the meshes, first step is number of unknowns 3. Number of unknowns 3. That means you require 3 equations. You require 3 equations. So how to get these 3 equations is the question. Okay. First step is this is what is called as source quantity of dependent source. So 15I1 is called as dependent source value. So relate this I1 with mesh currents. Relate this I1 with mesh currents. So in the figure I1 is here, I1 is same. So the 15I1, there is no question of representing the source quantity in terms of mesh currents. Therefore I1. Next is I1. Therefore I1 equals I1. So we have represented. Next is you apply KVL to the mesh that do not contain current source. Now first, if you in mesh 1, that is I1 mesh, there is no current source. You can apply KVL. Applying KVL, it is 10I1. Next, plus 20. I1 is in this direction, I2 in the opposite direction. 20 into I1 minus I2. Next, plus I1 is in this direction, I3 is in this direction. Therefore 30 into I1 minus I3. Rise in potential of 80 volts, that is minus 80 equal to 0. So this is one equation. The next equation is we have to create what is called as super mesh, because this is a current source. The current source is in the middle. Therefore we have to create what is called as a super mesh. So super mesh is created by using the branches of second mesh and third mesh. Now this is super mesh. I have explained in the previous class what is super mesh. So super mesh is nothing but a closed path using the branches of the meshes uncommon. So here this is what is called as a super mesh. Now apply KVL to this super mesh. You traverse like this. If you traverse here in this direction, rise in potential minus 30. Okay, minus 30. Next, plus 40 into 40 into I3 plus 40 into I3 because I3 is this mesh current. Next plus 30 into I3 minus I1 because we are traversing in this direction. Therefore 30 into I3 is this mesh current, I3 minus I1. Next plus 20 into I2 is in this direction, I1 is in this direction. Therefore I2 minus I1 equal to 0. This is second equation. So first equation is obtained by applying KVL to a closed path that do not contain current source. Next, and having created a super mesh, we have applied KVL, and this is the third equation. Now the question is how to get the third equation because there are three unknowns. So we have to solve three unknowns. Therefore, I require one more equation. Now I have arranged equation, these three simultaneous equation as 60 I1 minus 20 I2 minus 30 I3 equal to 80 and others too. If you solve using scientific calculator, I1 is equal to 0.58 amperes. I2 equals minus 6.15 and I3 equals 2.6 amperes. Now I am interested in only I3 because I have to find voltage drop V3. So it is coming out to be positive. That means assumed direction is correct. Therefore, what is V3? V3 is the voltage drop across 40 ohms. Therefore, V3 is equal to 40 multiplied by 2.6. That is 404 volts. So this is how you have to work out type 4. So in type 4, you will come across dependent source. The dependent source quantity is to be related with mesh currents. That is one step. Another step is, this is a current source which is in the middle. Therefore, to get one equation, I have to create a super mesh. In the next class, I will take problem with a dependent voltage source. You can also work out problem using dependent voltage source. Thank you.